In this podcast, we're going to talk about triacylglycerol structure. You may have heard this term before. There's a shift. We used to call them triglycerides, but we're now calling them triacylglycerols. You're going to hear me call it both because I cannot make that shift. We're going to talk about the structure, and we're also going to talk about some foods that have certain triacylglycerols in them. Triacylglycerols are essentially triesters. There's going to be 3 ester bonds in them. The alcohol portion, so the alcohol side of the ester, is going to come from a special alcohol that we call glycerol. You are going to have to memorize the structure. Will come up soon. And you also have an acid portion, so the carbonyl portion of the ester is going to come from fatty acids. So you can imagine that we're going to have these really long carbon-hydrogen chains, which comes from our fatty acids. So glycerol is the structure right here. This is one you are going to have to memorize because you're going to have to be able to identify it. So glycerol has 3 hydroxyl groups on it, and it's bound together by a backbone. Oftentimes we'll refer to this as the glycerol backbone in a triacylglycerol. All right, so let's go through our general structure for a triacylglycerol, and then I will show you that in an actual structure of a triacylglycerol. You're going to have a glycerol backbone, so this is going to be your glycerol. And then coming off at each of these portions, because this is how we form the ester bond, you're going to have 3 fatty acids. And this is tough to write on, so I'm going to abbreviate my 3 fatty acids with just Fa coming down here. So we have in each of these alcohols, that alcohol, that hydroxyl, is going to react with the carboxylic acid portion of the fatty acid, forming an ester bond. This is an esterification reaction. Again, you've learned this last unit. We're just using it in a little bit different way. So here's an actual structure of a triacylglycerol. Let's go ahead and identify the portions of it so you can see where they all came from. So here we have our ester bonds. And we have 3, almost did not include him. We have 3 ester bonds in here. This backbone, and I'm going to include the oxygen because this is where the alcohol came from. This was from our glycerol. We consider that our glycerol backbone. Finally, you're going to have long carbon-hydrogen chains. These can be saturated, they can be unsaturated, they don't have to match each other. You could have 3 different chains. In this case, we have 3 identical chains. Notice the abbreviation here. You have 16 carbons plus 1 makes a 17th plus another. This is an 18 carbon carboxylic acid. In this example, we're seeing them all as the same fatty acid added, but again, you're going to see them with different fatty acids. So this came from the carboxylate portion. So this was your carboxylic acid or your fatty acid that came together. Your carbonyl also was part of that fatty acid originally, but we're starting to draw on top of each other. For a quiz or an exam, you're going to want to make sure that you can get the structure and identify the different parts of it. You're also going to want to make sure that you're able to recognize this specific lipid versus a wax versus some of the other lipids that we're going to look at. All right, so if you've listened to anybody over the age of 30 talk, you've probably heard them talk about their triglyceride levels. So we're very concerned with the amount of triglycerides or lipids that we have floating around in our blood because that can be an indicator of health or other issues. Of course, now we're calling them triacylglycerols. So this is an example of a solid fat or a solid triacylglycerol. Notice that there are no double bonds in my fatty acid chain. It's all single bonds. So you know that these guys are going to pack tightly together when there's more than one, and they're going to be solid at room temperature. Something else to note, and this is a little tricky to see, I am going to pick out my glycerol portion. Ooh, right there. That's my glycerol backbone. I would never give you a ball and stick model and ask you to find that because it's a little difficult when you can't turn it and twist it. But I can see my carbonyls right here, and that is what begins each of my fatty acids. So there's 1 fatty acid, 2 fatty acids, 3 include him, 3 fatty acids. So depending on what your hydrocarbon chain looks like in your fatty acid, that's going to dictate whether you have a solid triacylglycerol or a liquid triacylglycerol. And remember that usually your solid fats are going to be from an animal source and they're saturated. The exception is always coconut oil. Coconut oil is plant-based, but it's also solid at room temperature. It has a lot of saturation. And here's an example of an unsaturated triacylglycerol. So again, we're going to see that glycerol backbone. I'm just snagging the oxygen, the single oxygen side. That's my glycerol. And then I have 3 fatty acids coming off of them, including my carbonyl in this, because the carbonyl was part of the carboxylic acid or the fatty acid. Notice on this last one, we have a cis double bond right there. The cis double bond gives it that crazy kink in there instead of being straight across. That means that these guys with those little bumps in them are not going to be able to pack very tightly. They're going to remain liquid at room temperature. So in this particular triacylglycerol, it looks like we have 2 fatty acids, and I would have to count the number of carbons in them, but we have 2 fatty acids that are the same, and then we have 1 unsaturated fatty acid that's going to give it its physical properties of being liquid at room temperature. Typically, with coconut oil as my exception, these are going to be plant-based lipids. We're going to touch on this a little bit more in class when we talk about hydrogenation reactions, but I think it's a great place to put this in. A lot of foods have trans fat in them, and if you pay any attention to the news, you know that the news is telling us that trans fats are bad fats for you, and they're essentially right. We don't usually see trans fats in nature. Usually they're cis fats. So here's what's going on. We have a triacylglycerol that we're using as a fat in a product. You need to have fats in your products. You need to have fat in your diet. But the kind of fat can really make a big difference in health. And when we get back to lecture, we're going to talk about the health consequences of these in lecture. So make sure you show up. All right. So originally, this had a cis double bond. And what we can do is we can partially hydrogenate, meaning we can take out some of our cis double bonds with hydrogens. We can break the double bond into a single bond. When you see something that is partially hydrogenated, that's essentially what's happening. We're taking out the double bonds that also make it liquid at room temperature, and we are creating something that would be more solid at room temperature. And this has some benefits for the consumer because instead of having a food that has a very oily feel from a liquid oil, we now don't have that oily feel and it's more of a solid feel. However, there's health consequences associated with that. So here we have, this was manufactured artificially. We have a trans double fat. So technically, this is unsaturated. But because it has a trans conformation instead of a cis, notice that it's in a straight chain. It doesn't have that kink. Because it doesn't have a kink in it, these guys can pack tightly together, and they're going to have the characteristics physically of a solid fat. They're going to be solid at room temperature. They're going to have the same characteristics as a saturated fat. So we technically get to say we have some levels of unsaturation, but because of the trans fat, they're going to have the characteristics and they're going to be treated by your body the same way as a saturated fat. So it's pretty unhealthy for you.